Okay, so let's have some sound check. Let's check sound. Good afternoon, everyone. Let's see if you hear me and if the sound is okay. So I see we have a couple of viewers, and let's see if we have sound. Okay, awesome. Then let's go on with the lecture. So this lecture is about system testing. So now we are talking about testing the entire thing. And we are gonna take another step back from actual testing, which we have talked a lot about in the previous lectures, to planning things and to think about what would we want to be there if we were going to do testing of some kind of software. And this lecture is hopefully useful for your assignment 2, because maybe you will see traces of this in the documentation of the different softwares that you're testing. So let's go on with that thing. So first, I would like to have a strategy. It's usually when we have limited resources, we need to come up with some kind of plan to not spend all time on something that is not useful for us. So a strategy essentially means that we have goals and then we have means. So we have something we want done, and then we have some money or some means to do that. And the strategy is essentially how to reach the goals using the means. So not difficult at all, but we need to have these two components. We need to know what we want, and we need to know what we have in order to do that. So let's have some examples. Usually when we have a goal, we want to have also a stakeholder. So someone wants something done. And since this is course in testing and not just anything, we want testing goals. So when we're planning testing, of course, we're talking about testing goals. So let's have two things. The first one, the web shop owners want the full process of shopping tested every day. This to make sure that customers can fulfill purchases. So every day we want to make sure that if we have a web store, that someone can buy things. And we want to test every little step in this chain of different events that happens. So this could be, putting a product in the shopping basket, say that we want to buy them, go to the place where we fill in, where we live, and then going through the payment system, and then making sure that everything happens there, and make sure in the end that an order has been produced, that money comes into the right bank account and stuff like that. That is a goal. We want to make sure that that happens every day, for example. So, this is just a made up goal. But if I had a web store and I was, earning a lot of money, if the web store is functioning and working, then I would maybe want to make sure that this is happening. So I could, come up with this goal. It may be unreasonable for some web stores because maybe this would require us to buy things in the actual store. So we would need to have a budget for that. Of course, we're going to get the money back, but probably such a purchase process still costs us money. It will also introduce a lot of false orders into our system, so it will have a cost, right? Let's try a more reasonable one, perhaps. The first one could be reasonable if you have a large enough web store. But the second one, okay, developers want to be able to refactor their code without destroying existing functionality. So they want to be able to know if they destroyed anything when they change the code. So refactoring means to rewrite code without changing its function. So we're not introducing new things, we're just rewriting the code, perhaps to make it more understandable, perhaps to remove duplication, perhaps for some other reason. But I mean, this is something that is a huge deal for most developers. I've heard developers say that if I'm not, feeling that I can work freely in this code, then I will swap company. So, and I would suggest you to make sure that the way that you work as developers, when you become developers, that you make sure that the process, that you like every step of the process. So I took this as an example just for that reason. So, I mean, developers would want that. So how would we know if we did destroy anything? We would like to have automated unit tests for everything, perhaps, right? But this is the goal, and then we're going to get means, and then we can decide what to do with the means. So if we have, I mean, huge means, then we can do this. I mean, if we have huge means, maybe every hour in the web shop, we are actually randomizing a couple of products. If I have unlimited means, maybe I have a tester, a person actually buying things every day to make sure the web store works, right? And, we're actually giving the stuff to that tester as salary. I don't know. Perhaps that could be a thing if I have unlimited resources, right? The second one, to refactor their code without destroying an existing functionality, that could be realized through different things. But in order to understand what we're going to do, we need to understand the means. And the means is I think of it as a budget. So you have time, for instance, in the budget. So we have a week of 40 hours or something like that we can work on this. It could be not only, I mean, number of hours. Number of hours usually translates to some kind of money. So the tester or developer costs this and this much money each hour. So we just want to spend, let's say, 5 hours or 20 hours on testing or something like that. So you get a limit on how many hours. But it could also be scheduled time. So we know that we're going to release this feature on Friday. So we need to start testing it directly now, or we have just this week. It's going to be released on Friday. So we need to make sure that we get time to test it before. Friday was an example of deadlines, but this could also be scheduled time. So in the budget, like the tester, the person that we want access to, only have time on Tuesdays. So we must make sure that we get enough Tuesdays in order to test that. I mean, the budget could be anything. It could be money also, right? In the end, most of these things comes down to money. It could be people. So let's say that who do we need in order to test this? And if we have a couple of experts in something, maybe we need access to those people. Of course, if we have a specific group of testers, we need access to those people. Maybe they are working on other projects. Maybe we want to do like beta testing with customers, or we want to have acceptance testing with a customer. Then maybe, okay, we need access to these things. So they are part of our means. Thirdly, it goes without saying that we need the equipment in order to test things. And this is usually quite problematic when it comes to developing new software that runs also on new hardware. Because if you have new hardware that is coming up, let's say a new PlayStation version or something like that, you want to release a new version of something to the new version of the hardware, and that is something that you don't have yet, so perhaps you're developing on computers or something like that. But in the end, if you want to test it on a specific hardware, you need to access to that hardware. So the other week, I was in Växjö and talking to students there, and they were talking about these problems within their projects. So they had they needed a specific. Yes, they need specific sensors in order to do their project, but these sensors could not be available before the project ended. So that could be a big issue, right? But I mean, equipment could also be spaces to do testing in, and really anything that it's needed. If you're gonna buy stuff every day, maybe you need a credit card for that web shop testing also. And then you have already seen JUnit, but there are other tools. Some are licensed, some you need, to pay for. But there are other tools now in assignment 2. You've probably seen, hopefully, you've seen things like Cypress or Selenium or Puppeteer or other tools that can be used to test web softwares. There are a number of different frameworks and testing tools that can be used. But these can also be tools that are needed in order to run the actual system that we're gonna test, right? So we need access to the system itself or tools that allows us to run that. Really, anything that is input that sort of costs something for us in order, that is our means. And if we are working on a project, we need to ask for this probably. People are gonna give us these things, so we need to make sure that we get them. So when we know how much we can get and what we can get, then we can make up a plan to reach our testing goals with the means. So if I don't have access to experts, what can I do? How can we reach our goal still, right? So if we have unlimited budget, of course we can do crazy stuff. We can, let people buy stuff and they're gonna keep it. But maybe we don't have that. So then we need to, be creative to reach the budget and reach the goals and keep within the budget. Sometimes it's not possible. If people are not giving you anything for doing a lot, then you cannot do it. If there's not time, then you cannot do it. So, okay, so the strategy itself is to reach the goals with our means. So I have an example here. So since the application is relatively stable and deployed, we want to test the shopping requirements. Use case 2, using fully automated system tests on the active system. These should run nightly to ensure availability and uptime. So here suddenly we have gone from a goal to how to do it and decided. And we have decided a lot of different things, and we sort of also talk about why we chose this, right? So we want the application is relatively stable and deployed, which means that, okay, we can run fully automated system tests. The fully automation is, depending on the budget. So if we have unlimited budget, maybe we would have chosen something else. Yeah. These should run nightly to ensure availability and uptime is also the budget thing comes into mind there. Okay, we're going to run this on the actual system. So let's look at the time where the customers are not heavily using the system to not disturb them. So this is also a way of showing that. And this is just examples. Often if we're working in some kind of iterative development process or agile development process where we have iterations, each iteration want to do testing, and then suddenly the budget is divided between different iterations, and we need to split our effort into the different iterations. So it could be a good idea to talk about, okay, what are we going to do for testing this iteration? What are we going to do next iteration? When perhaps you need to, spread your resources a bit over these. So this is an example of that. In this iteration, we focus on add system API, since the developers released a new version, but also run regression tests on the login system that was updated. So both of these things make sense because, okay, maybe if we've just developed something, that is probably going to be full of bugs. And if we have updated the login system, we really need to run the tests again for that. In this case, the wording here suggests that the tests themselves are pretty expensive. It could be manual tests or something like that. So we don't want to run, login system regression tests every time. If we are having a strategy that is highly focused on automation, then we would like to, run every test every time. And I mean, that is sort of the goal, but sometimes, and you've heard the story about the German car manufacturer where the testing process took 2 weeks. So I mean, not every system is that easy. So, so let's make up a plan where we have this strategy as one part. We have sort of budget and everything in that, the budget and the goals, and then we make up a plan. So what are we going to do? And I think the first thing that we want to decide on, what is going to be tested, like there was in this one, this ad system API and the login system. Which requirements are we going to focus on? Usually we would like to focus on stuff that has been implemented. But this can, I mean, if you have limited resources, maybe you're just focusing on important stuff. Or we divide our resources. So which requirements are we going to do? We divide our attention among the functional and non-functional requirements. Perhaps some are more critical to test than others, so we prioritize up them or spend more resources on them. The non-functional requirements can sometimes be dynamic qualities in the code, like how fast does this run? We want to have an access time or a response time of the system within some specific limits. Yeah, we can prioritize these requirements or these, of course. Is there some part that is more critical than other parts? Maybe the authentication system is more critical than some other part of the system because we really don't want to have people accessing the system that should not be there. And I mean, in order to understand this, we need to understand the general goal of the system and the general, not just the testing goals, but the business goal of the system in order to decide this. Like I talked about earlier here, if we implemented a part, maybe we prioritize the testing of that part. Maybe if we're doing test-driven development, we're always testing before we're implementing stuff. And of course, you also decide we have done this testing. Perhaps we've done some testing that is expensive, like manual testing. So maybe we need to do that again because we've changed something. Or last iteration, there were some tests during manual testing that failed. We need to redo those things because now we have new implementation. We need to make sure that everything is working. We can decide on code components. Okay, this has been updated. Let's test that one. And finally, in order to support this, in order to be able to regression test only these components that have been updated, we need some kind of traceability between old test results in order to be able to make these decisions. We need traceability between code components and requirements, for instance. So we can see that some components have changed, and we need traceability between those components and the requirements that they implement. For instance, if the authentication system has been updated, we need to understand which test to run, really. So traceability is an important thing. As important for a test plan as what to test, we can also say what not to test. So, I mean, these are just mirror images, but sometimes it's easier to say that we're not going to test the backend this iteration. And why are we doing this? Because if we're writing a plan should guide people's work. So we need to make sure that people understand what they're going to do and why they're going to do it in order to be, with us on the train. And a test plan like this could be informal. It could be a number of people talking. this is the things that we're going to do. And I've heard some software companies where they have daily stand-ups, and they sort of decide everything at the daily stand-ups, and they don't have any documentation. There are other places where they really need the documentation. The system is big or complicated, or there are so many different people involved, you cannot really have stand-ups with everyone. Or the project is living so long so that, I mean, developers get replaced, they need to read up on everything. We cannot rely on people to have things in their head anymore. Okay, so when we know what should be tested, then we can think about how should we test it. And I think a good starting point could be to talk about test levels like we talked about earlier. So the test levels that we talked about was, the lowest level was unit testing. Let's just have a test for each function, or a couple of tests for each function, like assignment 1. But this is really, really low level. It's far away from the requirements. It's on this level, it's hard to get traceability to the requirements. So if I say the authentication system has changed, or the authentication requirement has changed, there is often not an easy way to know which part of the code is connected to the authentication system, unless you componize. You have a specific component for that is like called the authentication system. Okay, we could also talk about integration tests, so we're writing tests on a bit higher level. When we come up to this level, we are combining classes, and maybe we are not as thorough in our testing of every single case. We're maybe no longer thinking about different inputs for one function. Maybe we're building bigger things, so we're testing fewer things, right? And this can go all the way up to system testing, where we're testing the entire system. Maybe we're building end-to-end tests, so we're testing the system through its input, like with Cypress or Selenium. And we are making sure that everything works all the way down to the back end, or the APIs in the back end, and then back to the surface again on the user input. This level is, most projects that have a user interface want to have some kind of system tests, and now we want to automate them also. So we try to write test cases that can be automated. So we are very specific with our input and very specific with our output. As we are testing a bigger part of the system, exactly like when we thought about smoke testing, when something does not work, we don't have the accuracy of finding the exact thing that did not work as we would have with unit tests, where we have really, really good accuracy. Sometimes we have problems with both controllability and observability when we're on this level. But it seems that with the coming of Selenium and Cypress and other tools for automating the web browser, or automating testing in the web browser, then this is usually the level that most projects test today. I think a good starting point for doing system tests is to write manual tests. So you write this test either directly in such a tool as Selenium or Cypress, or you are actually just doing things manually and documenting those things. The nice thing with manual tests is that you can give them to someone and they can test the system using these, like within an acceptance test. We also need to decide how to do things. We should decide on the level automation. What are we going to do automatically? Are we going to do some stuff manually? Because perhaps some stuff are easier to test manually than installing a new framework for automation. If we have very small user interface, maybe it's easier to just click once in a while, click through it. Maybe if we have a complex or a little bit more complex user interface, maybe we want to do some exploratory testing, just to make sure that things work even if people are doing strange things. By now, I hope you've seen the exploratory testing video by James Bach. Yeah, so I mean, this exploratory testing, according to James Bach, requires some experience. So he's talking about following his intuition on tracing down bugs and stuff like that. And I guess having someone that is an expert on this could be expensive. So do we feel the use for that, or should we, let someone learn this? When it comes to technologies or ways of testing, beta testing is also a thing, right? Let's bring in some customers, let them try the new version of this, or let's find some people that from our target group and let them test this. And that sort of feedback we're going to get from them is different from the kind of feedback we get from an exploratory tester or someone that is knowing our requirements. Because a beta testing group is going to talk about, the colors of things and how they liked it and stuff like that, and not just if the thing worked or not. So we want to make sure that that sort of information comes in the right moment in the project, and that this suits our test goals also. And also, do we want the customer or not? Then finally, if we're gonna do this, how do we know if we're having an okay test result or not? And if we're not having an okay test result, what should we do? So the testing itself is a feedback mechanism, right? So we want the feedback triggering something. So if you're developing code and you're running a unit test and the unit test is not functioning, then you're using the unit test to debug, and then you're working on it until it's an easy way, right? But if you have other goals, then maybe you need to decide perhaps this is good enough or this is not good enough. So let's have a testing goal like programming lead wants high code coverage. Then we need to define what is high code coverage. So we could say that, okay, we want unit test coverage for the system to be at least 85%. So I think we did see 90% as a goal for one project today in assignment 2. So, okay, but that goal itself is just going to give us a Boolean. We reach the goal, we don't reach the goal. So in order to get some action done, we need to decide on that action. So who are we going to talk to? What is going to happen? I don't know if there was some action related to that. I think in the documentation that we looked in today, it said that if you don't, you cannot commit or you cannot merge when you're not having 90%. So that could also be a way of actionating these goals. But it could also be things like customer wants all main success scenarios to succeed, and then we have something that we can measure. These 2 test cases should succeed, and then the action, if they don't succeed, is that, oh, these are going to be our focus for the development, the next iteration. So the entire thing with the plan is to drive people's work. So it's a way of collaborating and a way to decide on what we're going to do and how we're going to do it and what we're going to do if it didn't work, and come up with the thresholds of different things in order to make people work. So if we are alone and we're just, developing our hobby project or something like that, I never wrote a plan. But I was still doing the things that would be in a plan. I was still, trying to test my code. I was, saying that this is not good enough. I need to do this because this other thing happened, right? But the reason that it could work is that I was alone. When we're a couple of people, if we're, sitting next to each other, maybe we can talk about these things. But if we're more spread out, then suddenly, or many more people, then we need to decide things more systematically. So it's a plan. It should guide the work effort. And in order to guide people, in order to do things, if you have more than one person, you need to decide who does what, right? So who is responsible? Who will implement a specific test? Who will run that test? And if we need some vital information, if we need some means, really, who has that? And then we decide who is going to use this result. So I think so much work is done for the sake of doing the work. And often we forget about the last one, who uses the results from this. So I know in my work as an employee here at the university, I create a lot of these paper products. And many times I feel that these are not used by anyone. And sometimes I am on the receiving end of these paper products, and I look at one line of the paper product. The rest is just, I'm not interested in that. So I think to ask who is responsible, who is going to use these results that you're producing, whatever you're producing, so that you think about it as a chain of people that are doing things and that are going to get actionated by this plan. Yeah. Okay. Then people working means maybe there, maybe not there. There are risks. Things are going to go wrong, as with all plans. So planning is everything. Execution, yeah. But during execution, shit is going to happen. So you need to think about risks and what can affect our testing process. So like for the students in Växjö, they didn't have the sensors. How are they going to test their systems without the sensors? And should they wait with testing these things? Should they, buy another sensor? Should they do all these things? So we need to think about, yeah, what can go wrong, really. So in order to do that, I think one of the good things is to think about prerequisites. So we think of what is needed in order for one person to work, and then we make sure that that person gets those things. Yeah, the test environment is also a big thing. We need perhaps a test environment. Someone needs to build that, and maybe we cannot test the system before we have that. Yeah, I wrote an uptime on test system, access to test specific equipment, access to test personnel. And also, if we have all these risks, what are we going to do to minimize the risk and the effect of if this risk happens? Minimize the risk. So I think we're going to have a short break, 10 minutes, and start again 1600. Okay, so we're back. We're talking about the test plan. And I mean, planning is something that is important, but sometimes we underestimate how hard this is. And this is something that we, need to practice, but only if we have people to practice on, so to speak. So I just want you to get an idea on the different things that are involved. But let's continue with this part of it. But if we're planning, and the goal is communication, so make sure that you are communicating and not just planning. So how we communicate efficiently depends on who are communicating. So if we're not using the correct language, or if you're not writing the correct things, then we're not communicating efficiently. So people don't want to read a lot of documents. People generally don't want to do that. People want to, only read what they are going to do and stuff like that. So when we're formulating a plan, we should make sure that it's very clear who should do what when. Okay, so in order to understand this is exactly like the assignments you get, right? So you're asking a lot of questions because I'm not communicating good enough, perhaps. So in the end, we need to also decide, okay, how are we going to present the results of this testing? And this depends on who is going to be using these results to do something. The best thing is, I think, if we are using the results ourselves, then we as developers, we start to create the kind of results or the presentation of the results that we want. So we're sort of asking the testing activity questions, like which test failed. Maybe I'm only interested in which test failed. I'm not at all interested in who succeeded. Maybe it's good enough to know that, okay, 3,000 tests succeeded and 4 failed. But the 4 tests that failed, I'm showing 3 fingers, the 4 tests that failed, maybe I need to know their exact names. So, of course, for test frameworks, there are different presentations. A lot of the tools like JUnit and so on can, you run a command line tool and then you get some kind of report in HTML or something like that. But perhaps this is not the format that you need in your project, and therefore maybe you want to change this in order to streamline your project. I think one of the things that are generally missing when we write code is that we don't have traceability to requirements unless we sort of encode that into the code somewhere. So if we're planning something, who are going to get the information? How is the information going to look like? We could have a test report as an artifact, for instance. But we should only have a test report as an artifact if someone wants to read it, needs to read it in order to do something else, in order to decide something. So, so it's going to read it, where it's going to be stored, and how should we act on the test results? And finally, when are we going to have this done? So this sort of test plan things is, I would say, was a remnant of pre-agile testing. So when we had more waterfall-like system development processes, where we need to plan everything in detail before we start working. The agile way is more agile. So we are, this test plan became much, much smaller. We're only focusing on one iteration. And this makes it easier also to do this planning. And perhaps we don't need to have an actual test plan as a document. So in the assignment 2 projects that you look through, there may be all different kinds of traces of this. And in some of these there won't be any trace of a test plan or something that is named test plan. But perhaps you're still going to see the traces of these things in perhaps in forum posts, or developer discussions, or commit histories, and all these different things. So look through things, see if you can find out how they work in these projects. And this should be interesting for you, because soon you're going to be out there working in different ways. And I want in assignment 2 that you try to find out what is interesting in the projects that you are testing. And then during the workshop in January next year, you're going to present those interesting things to your fellow students. So when you're doing the presentation, think about the target audience for that is other students. It's not actually me. I'm going to be seeing, a couple of these presentations, but most I'm not going to see at all. So think about, what do you want to give to these other students? And this could be, if you find out about a cool testing tool, maybe your presentation is mostly about that tool. Maybe you don't talk about your project itself. You're just talking about how they tested. Or if they wrote their test in some weird way, but that you find interesting to see, or that if you found some trouble with their testing, maybe that is the interesting story. So with 5 minutes, you have time for one story, essentially. So think about, what is the most interesting thing to tell about. So you can have, since we are going to use slides, or if you have a presentation slides for this, it's going to duplicate as your hand-in also for everyone who is not looking for high grades. So then you make sure that you have a little bit traces of these things from the questions that are asked about projects, for every project. The other things, you can have a different documentation. Your sort of investigation diary or something like that. So for higher grades, for assignment 2, I want something a bit more readable, but it does not need to be, it's not an essay, right? So I want to see traces that you worked on these. Make sure it's traceable to the different questions I ask also. Okay, so I think we're going to switch presentation here and look at the other one. This one. And we're going to swap focus a little bit to generating test cases. So now we have a plan, perhaps, and we want to, get test cases done. And we've talked a little bit about these things, so you're going to see some duplication. So we've seen this requirements pyramid before. We've talked about the needs of the customers, something fuzzy and stuff like that. We define those as features, and then we generate use cases, or perhaps non-functional requirements in some specification or something like that. And then for each use case, you can have different paths through the use cases. And those paths we call scenarios. And when you put values on those scenarios, where you actually give test-specific input and test-specific expected output, then you have a test case. So I think I've shown the exact same use case before. The user wants to get access to a restricted system. User requests access, system asks for credentials, user gives credentials, system verifies credential, and present restricted access. And then, of course, there could be alternate scenarios where a user gives invalid credentials. So these are the different, or one use case, and that use case can have at least 2 scenarios, one where you get access and one where you don't get access. And then we can create test cases from those. So if you have a use case and you have alternate scenarios in the use case, then that is exactly like when we talked about the code and we wanted to have coverage of the code. We want to have coverage of the use cases and path coverage of the scenarios. So if we take a little bit more dressed form of that use case, you can see that I can graph the different paths, and then I can make sure that I get all graphs in my test cases. So number one starts when user wants to authenticate, which is the starting point for everything. And then number two either goes to free A or free, which is that you can have an alternate login scenario, which is called free A. So in order to find good test cases, you need to cover all the paths here. So you need to have 1, 2, 3, 4 test case, which is the main success scenario, and then you can have 1, 2, 3, 4A, 2, 3, 4, perhaps, or similar test cases. You also want to have one that is covering the 3A. Since we have loops here, we could think about the same thing that we thought about when we talked about coverage of code. We could think about coverage of, or loop coverage of these also. So maybe we need to go through the loop once, twice, or 0 times in order to sort of fulfill our coverage. And here are some examples of scenarios. So just from the same thing. We talked a little bit about test traceability earlier also, and the test traceability is usually when we generate test cases from use cases, we want to know things. We want to know if we are fulfilling all the requirements. Did we get all the functionality that was needed? We need to be able to focus our testing perhaps on main success scenarios or on alternate scenarios or stuff like that. But the reason for this is important is change management. So if either a requirement change or we need to change something big in the code, we need to understand how that affects things. Yeah. So a simple way of handling test traceability between use cases and test cases is the test traceability matrix, which I think I've shown before also. I think one of the more interesting things here in this one is that we have these numbers that sort of give some traceability between a test case and a use case. So test case for use case 1.1 is called 1.1.1. But I think that the interesting story here is that we want to use naming strategies, because these numbering strategies is just an example of a naming strategy. So when you have a specific use case or something like that, perhaps you call your components in the code similarly as the use case. So if you have a use case for authentication, maybe that is the authentication controller that is responsible for that use case, so that you get traceability between code and requirements. And usually naming things are good, but just notice that when you write requirements, you're talking in English, or you're using one language, and the code is another kind of language. Okay, on let's see, the requirements pyramid, we had 2 test cases to the right over here that were not use cases. So these could, for instance, be non-functional requirements. And non-functional requirements are things that are, they are not a story of, they are not functions. So non-functional requirements could be like the system is responsive, or it's user-friendly and stuff like that. And you've probably heard that every requirement that you write should be testable. And every non-functional requirement usually needs some specific type of testing technique. So, for instance, if we want to know if we're compliant to some kind of laws, the testing technique for that might be to check through all the software user interface to make sure that we're compliant with the law. If we're going to have usability testing, then perhaps we need a usability expert, or we have some checklists for usability that we follow. So it's a specific testing activity for that specific non-functional requirement. If you're doing performance testing, depending on the kind of system, you might need to, run specific tools that are only for performance testing. Localization testing, that is a specific activity where you perhaps need to change the language in the browser, or perhaps you also need people who talk different languages in order to do that. So the non-functional requirements, I would say, is specific testing skills and needs specific testing tools. And most of the things that we look into this course is, the functional requirements. We generate manual tests, or we generate unit tests for different things that are functions, right? But I think this is something that you should look for in your assignment 2 projects. And if you find some interesting non-functional requirement that, is specific for your project that is tested there, then talk about that during that workshop in January. Some experiences that I have is that it's very hard to come up with realistic goals for your non-functional requirement testing. So they can be hard to measure. So, for instance, even these that are easy to measure, like the speed of the download of the system or something like that. So performance testing, or response time testing or something like that. So we get a number back from the tool that is saying that it took one second or something like that to load the page. What are we going to do with this? Sometimes you get statistics back, so 1 second on average or something like that, and then you have a graph where sometimes it takes 10 seconds and sometimes it takes 1 second, and usually it takes between 1 and 5 seconds. Is this good enough or not? It's quite hard to know. Every time I've done it, I've thought about, okay, what does this result mean? And for some of these things, like the response rate of the system, we know that there are sort of truths for this. For some of these, you need to make up the truths, or talk to the customer and discuss these things. It's easy to make up that we need to run a lot of these performance tools, but no one is really interested in the results, or there is no action that you can do to improve these results anyway. So one of these tools is Apache JMeter, for which you can create a strategy for load testing or performance testing your web application. So I think we can look at these. Oh, it's called a test plan also. Things that you can set is, we're going to have a number of sort of threads or users, and we're going to have we're going to run this for so and so much time. We're going to call these different pages HTTP requests, and in the end you can get graphs and you can get statistics on how many of these tests that succeeded or not. I think there is a video on using JMeter produced from one student that had a lot of experience on that a number of years ago. So if you're interested in that, I suggest you take a look at it. Yes. I just want to remind you on the really the test selection problem. Exactly like when you're generating unit tests, we can generate how many tests we want. And you remember the name exhaustive testing is when we try to test everything, test every combination of input. And with manual testing, or even if we're generating system tests, it's the same thing. So we cannot test everything if we don't have a toy problem. So the test selection problem also applies here. So we try to select a subset of tests so that we reveal all errors in the program without breaking the budget. And I just want to remind you also that the goal of testing is to uncover errors and build confidence in the software. And sometimes, I mean, this Age of Conan image shows that sometimes it's, it can be funny, or even, it's not that bad if we still have bugs, right? But if you want to do something more important, maybe you need to have more effort, more budget. So given the seriousness of the thing that you're testing, and given the budget that you have, you need to decide on what is a good testing or ideal test suite. And I would say these are more or less my opinions. So we could define this as coverage, right? So we want, for instance, all requirements to be covered, or we want 90% of the code to be covered. So I would say as high coverage as possible. We don't want code that we have written that has never been run in a test. So we really want to have high coverage. Like a goal of having 90% coverage is probably a good goal. Have you heard about situations where it's hard to get coverage? And hopefully, if you're doing assignment 1 part 2, you will also experience that. But as high coverage as possible. And I would not feel happy with a project where we have code that has never been tested. Or don't have tests that we can repeat, I would say. Okay, the ideal test suite has high coverage. It finds bugs, if there are. Of course, it does. So coverage is not everything. It needs to also be powerful in distinguishing functioning versions or correct version of the software from incorrect or buggy versions. We want it to be automated to reduce painful regression. We want to run it really fast, also, as you heard before. So the system tests should also be automated. We want it to be easy to change when requirements change. So we want to have test traceability in order to support that. We would like it to be quick to develop, and that we can use it directly during development. So early testing and quickly testing. So maybe, and I've seen that in assignment 1 also, that some students have written, for instance, many test cases for the sum function. So the sum function was like, or the correct version of that, it should be like a plus b. So maybe we should not spend an hour writing a unit test for that. So quick to develop is something that we want. We also want to make sure that we don't repeat ourselves super much, so that it's also easy to read and stuff like that. An ideal test suite is also minimal. It should give enough confidence. It should find bugs, but it should not be cumbersome. It should not be a heavy thing to carry around and change. And it should be good enough for acceptance testing. So if I run my tests, I should feel confident that the system works and that I can release this version. So in order to do that, we make assumptions. And I don't know if you've heard it's called proverb, where the assumption is the mother of all fuck-ups, which means that when we assume things, we generally also make mistakes. So as an example, we want to have informed assumptions in order to make less mistakes. So one informed assumption could be like this: we only regression test modules that have been changed. So we make an assumption that modules that have been changed has more bugs in it, and that is just an assumption. We don't know that, but we let that assumption guide our work to minimize our work so that we can save, so to speak. Yes. Yeah, do we have? Yes. So exactly like when we talked about generating tests for just a function, we can think about black box. And when we think about black box, we are talking about input and expected output, but we're not really concerned about the code inside. So let's have a max function that takes 3 inputs. All inputs must be positive numbers larger than 0, and it throws exception on negative numbers. So using this one, we can talk about generate different test cases for that. Maybe we want A to be negative and make sure that throws an exception. Maybe we want B to be negative and throws an exception. Maybe we want C to be negative and it throws an exception. So we could have 3 different test cases. I mean, this is sort of unit testing methodology, but the same thing goes for any input. And then maybe a second test case could be where A, B, and C is positive. And we get where they are positive and A is the largest one. So when I think about this, I'm actually doing equivalence partitioning. So I'm dividing the input domain into different partitions. So for instance, we could have valid input and invalid input. And for the max function, the invalid input are the things that throws exception. So if A is a negative number, that is part of the invalid input, but the valid input is the things that make max return. So equivalence partitioning is dividing input into different spaces. It could be one-dimensional, like the valid and invalid input. It could be multi-dimensional also. So if you take the interesting thing with equivalent partitioning is that we want all inputs within one partition to work the same. So it sort of has the same general functionality. Like for all the negative A, B, or C, every one of those should throw an exception. So all of those are in the invalid. For the example add user, where we have an age, we can say that valid input for an age is 0 or 3 or 5 or 120. It doesn't really matter as long as it's between 0 and 120. But -5 is not a valid age, and 2 billions is not a valid age for a human being either. 121 could be debated as a valid age or not. So this, if you divide your input into different partitions, they need to be disjoint. And disjoint means that one number only exists, or one kind of input, or one input combination only exists in one of these partitions. And one strategy could be to select one test case from each partition. If I have white box testing, I have access to the source code in order to test things. And usually the source code decides the input domain. So if we take a look at this piece of code, it's not always easy to think about reads input domain as a black box thing. If I have access to the source code, it's easier for me to think about what happens. So if it contains a \n, then that becomes one part of the equivalence, one equivalence partition. If it does not, okay, then we have the second return statement. So if I have knowledge about the white box or glass box testing, if I have knowledge about the code internal workings, of course, I can use that information in order to generate these partitions. Okay, so partitioning can also be multi-dimensional, so you can have multiple partitions. So an example of that is that we have a function which says get loan, and people need to be between 18 and 65 to get a loan, and their salary needs to be over 25,000 pounds. So since these are two different axes or two different inputs, we first identify input domains for these variables. So 0, or since this is an integer for the age, negative ages are invalid, and all the way up to 17 perhaps is invalid for getting a loan. And then all the numbers from 18 to 65 is valid input when it comes to age, but 66 and above that is invalid again, right? So we have 3 parts of the input domain for age, and for salary, we need to have 25,000 pounds, so 24,999, and lower, including the negative numbers, are 1 partition, and 25,000 and above that is the second partition of the input domain. And when we have these equivalence partitions, we can combine them and generating something like this. So for the age, we have the 65 here and 18. And for the x-axis is the salary. And if I'm in this partition down here, I am too young and have a too low salary. If I'm in this partition here, I am too young, but I have enough as salary. If I'm in the blue partition, I am old enough, but I don't have enough money as an income. And here I am too old and too poor. And up here, I'm too old and too, but I'm still rich. But the E5 is the one that we're interested in. So if you have this kind of picture, then you could select one test case per partition here in order to cover all the different cases. And probably you also heard about boundary value analysis, which builds on that programmers often make mistakes on these boundaries between these things. So we use the wrong operator, for instance. And so a good way of thinking about this could be to use the numbers just on the edges of these boundaries. So when it comes to enough salary, we used 25,000 for the successful case, but we also used the 24,999 for the error case. And perhaps we want to make sure that the age is old enough or in the correct age. So we can select 18 and 24,999 and expect it to return false for getting a loan. So yes, and I think that is enough for today because we're a bit late and it's a slow lecture, many concepts. So thank you very much and see you.